doctor will see you now.
Let the doctor of the future give you his Panasonic cure with tiny creatures that unfold their features. An FM sound that turns your brain around.
Next.
His group prescriptions unleash a power that changes the future of human sound. Make your next appointment with Panasonic to examine sound band and triple tape. Panasonic, just slightly ahead of our time.
Håll käften, Orkan.
Papa, Mama,
Hej, hej.
I dagens Lyckeliv får ni bland annat se ett reportage från ett av de 3 museum för datateknik som existerar i världen. Och ett av dem, hör och häpna, ligger i Göteborg. Och så naturligtvis främmades i Europa på demos. fabrikens egen informationskanal. Vem är Sveriges snabbaste och bästa dataspelare? Vem uppfann datorn? Nobody. Här får ni se hur det gick till. Denna maskin som blivit ett gyllene skrin.
Vinnaren i dagens demotävling får reda på i Bit för bit nästa måndag, där även nya talanger visar upp sig.
You're watching Sleepcore. Pleasant dreams.
It's here, the first Nissan 300ZX, a technological marvel. Computerized, digitalized, civilized. The new 300ZX, powered by a new turbocharged V6. This sports car is awesome. Come alive, come and drive. Major motion from Nissan. At your Datsun dealer.
Ever since man set foot on Earth, he has been a creature on the move, traveling, exploring, always in motion. We have made a science of motion. We are Nissan, a major name on the road for 50 years. Behind every Nissan car and truck is advanced technology. Nissan is now perfecting vehicles that can run on hydrogen or electricity. Nissan has harnessed computers to control car engines and revolutionize dashboards, employing sensors and electronics to cool you, warn you, entertain you, guide you, protect you, and yes, propel you. At Nissan, we make driving more thrilling, more efficient, more comfortable. At Nissan, we make every drive major motion. Come alive, come and drive. Major See your Datsun dealer.
In the beginning, AT&T envisioned a phone in every home. We called it universal service. Today, our vision at AT&T has expanded and gone beyond even our wildest dreams. We call it the network of the future. Here to tell us about one of its components, advanced packet technology, Bob Lucky.
The map behind me is symbolic of the AT&T telecommunications network. It's vast, it's incredibly busy, and it's constantly evolving. One of the great challenges we have here at Bell Labs is guiding the evolution of this network and the customer premises equipment that attaches to it. One of the cornerstones of that evolution is packet technology. The state-of-the-art in packet technology today is for packetization of data only. Packet switches typically operate at rates of several hundred to several thousand packets per second, with delays on the order of several hundred milliseconds. At Bell Labs, we've developed advanced packet technology, which allows the packetization of speech and image as well as data.
In the past, customers have used the telephone, and that meant voice communication only. What our customers really want, we think, is a multimedia conversation where you don't just use the voice, but you use pictures also. It's really different whether somebody is typing at a terminal, we have only characters trickling through the system, or whether we have a picture coming and it's like an avalanche of information that goes across the network to your terminal. And this very big difference in the density of information that goes between the conversational partners in a telephone multimedia conversation is very well used by packet technology.
Bell Labs has also demonstrated packet switches that operate at throughputs exceeding several million packets per second at very minimal delays on the order of 10 to 20 milliseconds. So far, you've heard a lot about packet technology. It's time to see the real thing.
When I speak into this packet phone, it takes my speech, turns it into data, and fills up packets which are sent out on the line. Or the packets could have been data from my computer terminal. The other thing the packet phone has to do is to check the addresses on all the packets flowing by on the line to see if any are for me. If the address corresponds, it pulls those packets off the line and turns it back into speech or back into data from my computer terminal. That's a big job for a little box like this. And frankly, I was amazed that our researchers were able to put all of that technology into the single board you see in the base of this packet phone.
One of the advantages of the packet phone is that we've integrated the data and voice functions and integrated them into a local area network. Often, in the office environment, you're interested in having a voice conference and a data conference simultaneously. You may have a number of people talking about a document. You'd like them all to see the document and maybe even make editorial changes in the document while everybody else is seeing what's happening. You have this shared visual space, and in this visual space you are creating something that everybody agrees with and everybody can buy into. One of the things that distinguishes the packet phone from other data and voice systems is that we have found a way to give voice samples priority over the data samples so that if anything gets delayed, it's the data and not the voice.
The packet phone we've been discussing is intended for a local application, like within a building. There, your phone can examine the address on all the packets going by and determine which are for you. That's a simple job. But what about out there in the network, where you've got all those packets from everywhere that need to be routed? We're pursuing research that addresses this question. It's called wideband packet technology. We'll be discussing two of its elements, the access interface and the wideband packet switch.
The access interface is a very important component of the wideband packet technology network. What it does is it allows the customer to gain access to this packet network of the future. The access interface is, if you will, the gateway to the packet network. It is the conversion point where circuit switch services, voice, signaling, data, are all converted to a packet form.
An important feature of the access interface is embedded coding. This technique encodes voice at 32 kilobits per second, using 4 bits per voice sample. The voice packet has 2 bits in each sample that carry essential information, and 2 other bits that carry supplemental information. Under heavily loaded conditions, the supplemental bits can be dropped so that only essential parts are transmitted.
Think of all these packets carrying different kinds of information for different users, all getting thrown together and transmitted into the network and coming out again. How do we keep order?
Someone came up with the idea of a binary sort. Very simple, especially when done with modern microelectronics. Developed at Bell Labs, this idea has allowed us to build a switch that handles all the traffic out in the network. The wideband packet switch uses a distributed architecture, and the heart of this architecture is the switch node, interconnected in a matrix of nodes to form a distributed switching fabric. The fabric is self-routing and has the intelligence to direct a packet to its destination. For example, a packet with an 001 address enters at input A and is switched node by node through the fabric until it arrives at the correct output, B. A unique aspect of this design is that packets with the same destination can enter the fabric at any input and be routed to the correct output. So if a packet enters at C addressed 001, it will also go to B. This distributed architecture provides high-capacity performance required for future networks.
A little while ago, I referred to the evolution of the telecommunications network. We've seen that packets are a very important factor in this evolution. They represent a fundamentally new way of looking at communications, both for customer premises networks and for the AT&T telecommunications network. One 100 years ago, when Alexander Graham Bell invented the telephone, he could never have dreamed that someday we would be speaking to machines. Our research at Bell Laboratories has revolutionized the field of communications. With the advent of computers, we entered a new age of information exchange. With the advent of talking computers, this information is becoming easily accessible to all of us. The computer is no longer an imposing technology remote from human beings. Instead, it is becoming an integral part of our lives, and one in which there are limitless possibilities for interaction in all of our everyday activities.
Since the advent of computers, we have dreamed of talking machines that can easily share their information with us.
That's state-of-the-art speech synthesis, and it certainly doesn't sound very natural.
Well, that's for sure. Of course, the problem is that with a long sentence like this, the synthesizer really doesn't have access to the syntactic information and the information about the meaning of the sentence that it would need to produce a good version of the sentence.
Mm-hmm.
So maybe we ought to take a look at the syntax tree for this sentence.
A syntax tree is much like the sentence diagrams we did as school children. In this more detailed version, we see the subject and object of the main sentence, as well as the relative and introductory clauses. From the syntax tree, we create a prosody tree, which is different because the major nodes tell us how strongly various words should cohere together, and how large the boundary should be between various words.
So the result of playing this should be a sentence intonation that's a little closer to the way a person would say it.
Sure. Well, let's try this.
When we do our analysis, the result is that we want to have two breaks in the sentence. One here, between the initial introductory clause and the core sentence, and a second stronger one over here, between the core sentence and the relative clause that follows it.
Since the advent of computers, we have dreamed of talking machines that can easily share their information with us.
Well, that really was better, and I think it was better because this sentence really is awfully complex.
Mm-hmm. And that gave us a nice pattern of pauses and pitch variations in the sentence.
And it's exactly that pitch variation and the phrasing that goes with it that allows a listener to understand what the structure of the sentence is meant to be, and so to comprehend the meaning of the sentence better. Although what we're concentrating on is basic research into the underlying linguistic issues here, this is probably a system that will be useful for helping computers to communicate better with people.
A second area of pioneering research is speech recognition. Their initial goals were very simple: to train a machine to recognize single words and phrases spoken by a particular individual.
We've been working in the field of speech recognition for more than a decade, and improving both algorithms and hardware. First, we recognized isolated words from known speakers. Then we extended this capability to unknown speakers, or what is known as speaker-independent recognition. The ultimate goal, a most difficult one, will be the recognition of fluent speech.
There are a lot of problems we've had to face in our research in speech recognition. One of the very first problems is the variability of speakers saying words over and over again. They make small changes and in some cases big changes. A word like either might be spoken either one time and either a different time. A word like eight, which is a very simple word, you can say eight without a release, or you can say eight and heavily release the word. So we had to figure out how to handle variability problems. A second problem that was a major one that we thought was making the system so it was truly speaker independent. We had to develop a wide variety of procedures for looking at multiple patterns by different people and deciding how many patterns we really needed to actually represent the different words.
Today, our capability in recognition technology is limited. We can handle digit strings and sequences of words. In the following airline reservations demonstration, Larry Rabiner illustrates this capability.
I want to make a reservation, please.
Please specify your travel plans.
I want to go to Los Angeles on Monday morning.
Flight number 1 leaves New York at 10 a.m. arrives in Los Angeles at 12:50 p.m.
How much is the fare?
The round-trip coach fare is $388.
When will we have the capability that we see in movies like Star Wars or like the original Space Odyssey? Probably that will be decades away, where we actually have fluent speech recognition by a machine.
Ambitious goals often call for unusual measures. Speech recognition is so difficult that we humans integrate visual clues, like lip motion, as an aid in recognition. Why not give computers the same capability? That's just what we're trying to do.
Humans are remarkably skilled at recognizing speech in a variety of acoustic environments. Computers, on the other hand, do not have the repertoire of context, semantic information, or a world knowledge that is necessary in understanding language. Eric Pettijan has set himself the task of building a machine with a visual ability.
Here at Murray Hill, we're engaged in very basic research. This is the present head-mounted camera apparatus, a relatively cumbersome device. In the near future, we'll be mounting a very small camera on this microphone boom right about here.
The miniature camera is used to capture video frames of the face. Each frame is analyzed, and lip parameters are extracted from it and used to form a visual speech template. By combining this information with the output of the acoustic speech recognizer, the overall performance of the speech recognizer is improved.
The ultimate goal is to give the computer all of the sense modalities and all the facilities that the human being has, therefore maximizing the communication between the human and the computer.
Speech recognition is a hard problem, yet an even harder one lies ahead, and that is language understanding, the association of meaning with the words recognized.
The main goal of my research is to let people be able to talk to computers in their own language, for example, English, without having to go through a lot of training, and yet still be able to trust the system in terms of the correctness of the output that they produce. One of the main problems we find is the larger the vocabulary and the larger the number of English structures a system can process, the harder it becomes for the system to find a unique interpretation of a sentence. That is to say, the sentence becomes ambiguous, and a user wants to be very sure that what the system understands his sentence to mean coincides with what he intended. The system I'm working on answers typed English questions. As one example of an application of this technology, maybe I'm interested in vacationing in the Northeast. I call a travel agent and ask where the tallest mountains are, and that person might log into a computer that has information about the White Mountain National Forest. As another example input, I might want to know how high the mountains are on the Franconia Ridge, so I'll ask that question. How high are the mountains on the Franconia Ridge? Notice that since I had asked how high the mountains are, the answer included a table that was sorted in terms of highest to lowest. The processing techniques are in fact independent of whether the input is typed or spoken. So at some later date, when we link voice technology together with a system such as this, one will be able more or less to discard the keyboard, ask a question in a microphone, have the question processed, and in fact, in many cases, have a voice output as well perhaps as graphics on the screen.
As we have seen from this program, we are on the threshold of a new era of communications. Computers that can talk, listen, and understand. But what does this mean to all of us? This capability will ensure the transfer of valuable information to an ever-widening audience. To be sure, we have just begun this very difficult task, but we at Bell Labs believe it to be important for all of us.
You're watching Sleepcore, media for insomnia.
The year is 1990, and banking is still all about service. However, technology has greatly expanded that service. You can bank at work, in the street, the supermarket, the service station. Your credit card could be a tiny computer providing hip pocket reference of transactions. At your local bank branch, you'll be able to operate the bank's computer to manage your finances. It's still all about service, because now and in the future at ANZ, we'd like to be your bank.
Beneath these residential streets, a quiet revolution is occurring. Ameritech is transforming its electronic infrastructure with high-speed digital switches and fiber optic transmission technology, creating an information age network with the promise of fantastic new services in voice, data, and video.
If you're going to be the premier access provider in the information age, then your role is to be able to get information from any person, from any place, to anywhere, any format, and any volume. So if that's your goal, and basically at this point in time for what the residents needs, that's the phone company's role, and you see yourself keeping that role, then video is a natural extension.
As a matter of fact, a recent survey of customers did suggest that consumers did want more services from their telephone company in terms of information services and perhaps fiber to give options like high-definition television and cable, etc.
Fiber has the capability to deliver any and all, simultaneously or in series, whatever a customer wants. The issue will not be whether fiber is to the home and therefore we can move everything down that pipe. The issue will be what will people want. The pipe will be in place to get it there.
What services will customers want in the future? One possibility is the powerful new television developed in Japan with stunning picture quality and bright stereo sound. A powerful microprocessor transforms a simple television into a sophisticated computer. Advanced television is challenging the United States to redefine broadcast TV standards and may require fiber optic transmission. Advanced television could open a new service opportunity for Ameritech.
With high-definition television, the whole concept of two-way video communication could be revitalized. Now, this, of course, is speculation, but the potential is there because high-definition television on a two-way tailored connection basis potentially reopens the limitations of picture phone and possibly would then be something that the market would really want.
Two-way video communication is only one potential use of advanced television. Building upon the power of Ameritech's switched network, a wide variety of new services to the home could become commonplace. Advanced television will not only improve home entertainment, it will bring a computer into the user's home, providing access to a world of resources. Ameritech believes the information age might very well reach the home through television computers.
You're also able to provide access to other information sources where they may be things like databases of video catalogs where people can browse through video catalogs that are in a high-quality video format.
The home is going to be provided an opportunity of tremendously advanced services, information services. The question is, can we package those information services through applications that the consumer understands?
We're looking at what are the types of applications and services that telephone company subscribers would use based on a high-quality video signal. And we have to look at how are people going to interactively work with these different types of applications and media. And as visually, how do we communicate and how can we take advantage of the quality we have with HDTV and provide more than just transmission, provide advanced capabilities and access capabilities, intelligent network capabilities as well.
One of the biggest problems facing users of information services today is learning how to access complex databases. With advanced television and an electronic pointing device, Ameritech is studying how people can use new technologies to meet everyday needs in a simple way.
This is basically an improved version of your home television set. It's improved in a couple of ways. For one, the picture quality is somewhat better than you can get with your TV set now. And then it's what we call a smart TV set. There is a computer built in, basically. Although it is not visible to you, the user, there's a computer that's running the application and is able to do both drawing the screens and putting up the various graphical elements and also making requests of the network to bring in the pictures, which are really coming from a remote database. What I want to show you is an indication of how we think a visual interface might be used to help people navigate through a database of any kind. Now, in this case, what we have is a real estate service, perhaps maintained by a chamber of commerce or a board of realtors, where the idea is to help a person locate a home that they may be interested in buying. And what we want to do is use the visual attributes of the search to make it easier for the person to do that. The critical thing here is that I don't have to understand the nature of the data or the way it is organized, that I simply use the images and react to the images basically by pointing to them, so that I can guide the user through a very complex set of data in a very simple way. And we think this is a much simpler and more natural way for the people to come up and use what is really a very complex computer-based system, but without having to know very much at all about how it works or knowing the magic codes that you have to type in.
Ameritech Publishing is examining applications for its data. Although Ameritech is interested in many information services, current regulations bar the company's involvement. One future offering is electronic yellow pages.
If you think of our business and the fact that we have telephone directories with advertising appearing in those directories, we can someday put that advertising into a database, and then people sitting at home would have the ability to dial into that database and, similar to paging through a directory, retrieve information from that. I mean, that's the nature of our business, is trying to bring together consumers and advertisers. Let's just take some potential applications. Let's assume that you're sitting at home and that you peruse the menu and that it's to your liking.
Cheese, meat sauce. We have a black ravioli made from a kettle fish and a seafood and a shrimp sauce.
You then key information back and forth where you make your dinner reservation. You get your dinner reservation confirmed. You may be able to place your order right then in terms of what you like, wines, etc. You may have an indication of the total cost. You won't need to bring your wallet because you can key in your MasterCard or your American Express and do it all. You may be able to peruse a layout of the restaurant itself. All that done in advance just from your home. That today may take several calls or even an on-site visit. So, I mean, the applications are unlimited.
The information service is a delivery capability that one becomes unconscious of. Not unlike driving a car. One gets so used to driving a car that it becomes sort of second nature. And I really think that's what I expect information services will be.
By supporting switched video communications, by providing simple data retrieval, Ameritech is helping residential customers realize the benefits of the information age.